Yeah, no, I don't think so. In fact, I think this is where a lot of people are going to shift to. So, okay. Can you guys see my screen okay? Okay. So we're talking about just the intro here. So in hosted services environment, server storage and the supporting networking infrastructure are shared by multiple enterprises over a remote network connection. Cloud computing is a model for enabling convenient on-demand network access to a shared pool of configurable computing resources. Entities that offer cloud computing are called cloud service providers. So when we're talking cloud service providers, just throw out some names. I'm sure all of us think Amazon because that's a big one. Give me a couple more names.
Google.
Google. Anyone else? Come on. Cisco, technically, yep. Amazon, Microsoft. Exactly. So there's tons of them out there, and there's some big dogs like the ones we just did, and then there's some smaller ones, and then there's some like niche cloud computing services that you're seeing that have decided, okay, I can't fight against these big conglomerates, but I can do cloud services based off of this one section. It's really a big section, a big thing that you can get into. So the savings available through cloud computing are due to the following factors: elasticity and scalability, pay per use, on demand, and resiliency. Now, I will say, because I've been involved in several different where you go out and you look for new products and decide, do I want to do this? Do I want to do that? One of the big things that you have to pay attention to is their licensing. So there are a few of them that have a tendency to try and do pay per user, which can be good unless you're a huge entity, in which case it gets really expensive really fast. So yeah, it can get really expensive. Okay, so here's just your basic cloud computer. So you have your cloud vendor, router, internet, you have your Wi-Fi, and then you can see your enterprise LAN reaching out there. And this is just a different version of it. Cloud architecture. So there's a thin client, in which is a computer that runs from resources stored on a central cloud server. Has anyone used thin clients? Do you know what I'm talking about? Oh, good. You got some people that have used them. So, can one of you guys, like Mike, or can you give them an example of what that was like running with those? They suck. Yeah, see that's in my experience, it vastly depends on the type of hardware and the central cloud server that you're running from. You can get thin clients where they really cheap it out on the computer, the end computer, and they're like, oh, it'll be fine. And they'll either cheap it on one side or the other, and it always just ends up horrible.
Can you hear me real quick?
Yep.
Yeah, so I'll just really briefly detail my experience.
Yes, please.
Our thin clients were about the size of a router. It actually wasn't bad. They're actually fairly quick. The main issue we ran into is we were running a virtual machine within a virtual machine. So
yeah,
it's already kind of like what the hell. So the issue we ran into a lot was our accounts constantly getting locked out. We had to call the help desk that's over in Korea to have them unlock our accounts. And it is like, okay, well, you want the first virtual machine account or the second virtual machine account unlocked? And so it was kind of like a lot of back and forth went on. But other than that, they weren't really bad. It's just kind of frustrating to log in. Like, yeah, you logged in once, like, okay, now that you go through my email, get a link to the actual virtual machine that's through the web browser and log in that one also. So
yeah. Now that's an excellent example too. Thin client configurations can get really complicated, and if you make them too complicated, things like that happen. Transit Gateway is an Amazon Web Service. Anytime you see that AWS, that's Amazon technology that allows organizations to connect all existing virtual private clouds physical data centers, remote offices, and remote gateways into a single managed source. Serverless infrastructure is one in which the capacity planning, installation, setup, and management are all invisible to the user because they're handled by a cloud provider. Now, you do see this happen with, you're starting to see the small businesses try to do some of this because they really don't have the footprint to put in huge servers and things like that. So there are 4 service models in cloud computing. Most people have heard of SaaS, or software as a service. This is when the vendor provides access to the vendor's software applications running on a cloud infrastructure. There's PaaS, and that's platform as a service. Consumers install and run their own specialized application on the cloud computing network. Then there's IaaS, infrastructure as a service. The vendor allows customers to deploy and run their own software, including operating systems and applications. And then there's XaaS, which is basically anything goes. This one's a broad category of subscription services, just relating to pretty much anything. So cloud management can be conducted by a local organization performing the work itself, or you can contract with a third-party management service provider. Services integration attempts to achieve a boundaryless approach. This involves integrating all users across the enterprise who are using cloud computing. When locally managing cloud computing, an enterprise should have written resource policies in place. Now, this I've seen backfire badly when they don't, or when they have really broad policies and procedures that are just like, put the thing in the thing, and you're like, oh, okay, how does that help me? They must outline who is responsible for cloud computing, what their duties and responsibilities are, how cloud computing can be used and not used, and the process for acquiring the resources. A managed service provider, or MSP, delivers services through ongoing and regular support, as well as active administration of those resources. An MSP assumes the role of a traditional on-prem IT organization. Okay, so this is a nice little table. Security issues and description. So unauthorized access to your data. So this is improper cloud security configurations resulting in data being left exposed. If you ever want to see a big old list of different data breaches and stuff, if you don't know the site, it's called Have I Been Pwned, and I can put it out on there for you guys. You can search domains. Usually you need permission to do that, but you can search domains, you can search your email, or they have just a gigantic list of all sorts of different data breaches. And usually if it's a cloud, this is the problem. Lack of visibility. Organizations have limited or no visibility into the security mechanisms of the cloud provider, and thus cannot verify the effectiveness of the security controls. Insecure application program interfaces. While APIs help cloud customers customize their PaaS by providing data recognition, access, and effective encryption, a vulnerable API can be exploited by threat actors. That's the same thing as when you're talking about web APIs. It's kind of the same thing. Compliance regulations. Maintaining compliance requires an organization know where its data is, who can access it, and how it is protected. But it can be difficult in an opaque cloud system which lacks transparency. And then there's system vulnerabilities. The cloud infrastructure is prone to system vulnerabilities due to complex networks and multiple third-party platforms. So one of the other problems there is if you're relying on the third-party cloud system, you really need to know what's out there, what's being done, what's being updated, because you don't really have any control over that, but you still need to make yourself aware of their security. So, cloud security controls. Securing cloud computing involves using controls like the following: conducting audits. I cannot stress audits enough. I really think they're hugely important in all sorts of security. A cloud security audit is an independent examination of cloud service controls, and that independent part is also a big thing with those big companies. Use regions and zones. Reliability and resilience are achieved through duplicating processes across one or more geographical areas, called high availability across zones. There's secrets management. This enables strong security and improved management of a microservices-based architecture, allowing the entire cloud infrastructure to remain flexible and scalable without sacrificing security, and enforce functional area mitigations. And it looks like this is our next one on that. So, feature limited and automated replication. While secret data and secret names are protected global resources, the secret data is stored in regions which the user can specify on the cloud provider, or the cloud provider can designate. Secret specific versioning. A secret can be pinned to a specific version of the code. Audit logging. Every interaction generates an audit entry in a log file and can be used to find abnormal access patterns that may indicate possible security breaches. This is why when you're doing an audit, it's so important to look at log entries. Default encryption. Data is encrypted in transit and at rest with AES 256-bit encryption keys. Extensibility. One system is able to extend and integrate into other existing secrets management systems. Application security. One of the organization's security protections for cloud computing application security is the use of Cloud Access Security Broker, or CSAB. CASB, boy, I'm loving the typos on here. CASB is the set of software tools and services that resides between the enterprise's on-premises infrastructure and the cloud provider's infrastructure. CSB acts as a gatekeeper, ensuring that the security policies of the enterprise extend to its data in the cloud. Security virtual device solutions. Next generation secure web gateway, or SWG, examines both incoming and outgoing traffic and performs basic URL and monitoring in web applications. Cloud Firewall is a virtual software that functions in a similar manner to physical security appliance by examining traffic in and out of the cloud. So remember us talking about the hardware firewalls? This is basically just a virtual version of that. Lack of a cloud conceptual model. Physical networks use the open source interconnection, or OSI, 7-layer model to illustrate network functionality. With cloud computing, the OSI model is no longer as useful. The lack of a conceptual model like the OSI model makes selecting and managing security virtual devices more challenging. Different cloud-based conceptual models are starting to be proposed. However, no single model has been widely adapted. So that's the problem when you have something that's really new starting to pop up. There's no commonly agreed upon model yet. And I say yet because I'm betting we're going to see this in the next 5 years. So this is one of the examples that's like the OSI model, but is for secure cloud computing. So there's layer name, description, and party responsible. So layer 5, application experience, end user facing interface, and then the customer's responsible. 4, native service, create, store, and process, customer. Software defined data center, which is layer 3, creates, infrastructure. SaaS, cloud computing provider, PaaS, and IaaS, customer. Virtualization software on 2, software that virtualizes the hardware. So that's your cloud provider. And 1, your physical infrastructure, your buildings, power cables, hardware, utilities. And again, that's your provider. All right, knowledge check. Which cloud security control provides reliability and resiliency through the duplication of process across geographical audit areas? Conducting audits, implementing secret management, using regions and zones, enforcing functional area mitigations.
I feel like C is literally the only one that fits for that.
Yeah, exactly. Good job. Luckily, and I say this now because inevitably it'll change, a lot of the cloud computing they've tried to make match some other areas, but you see a little bit more common sense terminology on certain things. Virtualization security. Virtualization security involves an understanding of the topic along with specific examples, includes specific steps to be taken to secure a virtualized environment. So what is it? It means the managing boy, I can't talk today, and presenting computer resources without regard to physical layout or location. Host virtualization is a type of virtualization in which the entire OS environment is simulated. A virtual machine is a simulated software-based emulation of a computer. The host system runs a hypervisor that manages the virtual operating systems and supports one or more guest systems. Virtualization is used to consolidate multiple physical servers into VMs that can run on a single physical computer. The VM monitor program is called a hypervisor, which manages the VM operating system. There are two types of hypervisors. Now, if this sounds familiar, it's because we ran through it in a couple of our other classes too. Type 1, which runs directly on the computer's hardware instead of an underlying operating system. And then type 2, which runs on a host OS, and this is much like an application. A container holds only the necessary OS components that are needed for that specific application to run. It reduces the necessary hard drive storage space and RAM needed, allows for containers to start more quickly because the OS does not have to be started. So this kind of works like when you pare down Linux and you can use it for different versions because you've taken all those chunks away that you don't need, so things work a little bit faster. And here's an example of your type 1 and type 2 hypervisor. There's the type 1 on the left where it's got your hardware, and then bam, you've got your hypervisor right on top of it, and everything goes from there. Now on the other one, you've got your hardware, then your host OS, and then your hypervisor on top of it.
Which one do you personally prefer?
I've used both. And I prefer the one where you use hardware than hypervisor. It just seems to work better. I don't know why. And I don't know if that's just because of the way it was set up at the place that I worked. Because the type 2, the host OS freaked out a couple of times. So it could have been that they had some really cruddy configurations, and that's why. So have you guys used both, one, either? What do you guys
I've only
like?
ever used 2.
You've only had 2? Yeah,
that's the only one.
Usually
Go
most
for it.
people have experience with 2. I think 1 runs a bit faster than 2 does. Anyone else? Has anyone else used a hypervisor 1? Or am I it on that one? Not sure. Yeah, most people use the 2s, but if you ever get a chance to use the 1, just make sure to pay attention and see which one and if you like that better. So this is explaining your containers. So you have, this is a hypervisor 2, and then you have your containers right over here. You see your binary libraries and your applications that it's talking about. So what are the advantages of virtualization? New virtual server machines can be made available and resources can easily be expanded or contracted as needed, which is really nice when you think about if you're like, I need to update the server and I need to add more hard drive space, more RAM space, you know, you have to shut it down and add more physically to it. So it's more expensive, it takes more time, and that's that availability and elasticity there. You can reduce costs. Fewer physical computers must be purchased and maintained. And something else that I didn't think about until I talked to someone who actually did this, there's fewer physical space for where you have to put the servers, and the amount of power that your data center uses is drastically reduced. So that's also some less money there. Can provide uninterrupted server access to users, supports live migration, which allows a virtual machine to be moved to a different physical computer with no impact to users. Infrastructure as code. Software-defined network. An SDN virtualizes parts of the physical network so that it can be more quickly and easily reconfigured. This is accomplished by separating the control plane from the data plane. If traffic needs to flow through the network, it receives permission from the SDN controller, which verifies the communication is permitted by the network policy of the enterprise. Once approved, the SDN controller computes a route for the flow to take and adds an entry for that flow in each of the switches along the path. SDV, or software-defined visibility, is a framework that allows users to create programs in which critical security functions can be automated. SDV allows network administrators to automate multiple functions in a network infrastructure, including dynamic response to detect threat patterns, adjustments to traffic mode configurations for inline security tools, and additional IT operations management functions and capabilities. Security concerns for virtual environments. So security-related advantages of virtualization: you can test the latest security updates by downloading it to a virtual machine before installing it on production computers. So it's basically, you can go, hey, does this work? Nope. And you can roll it back without trashing your production environment. You can snapshot a particular state of a virtual machine and you can save it for later use. Another thing that I like when you do these, especially with servers, you snapshot your state, you go out, you mess with your server. If you trash all your configurations, you can roll it back to your snapshot. That is one of the best things for virtual machines, in my opinion. Testing the existing security and configuration. Security control testing can be performed using a simulated network environment, which is another great thing. You can go out there and take almost like an entire snapshot of your network and recreate it, and you're not tearing apart your production environment. VMs can promote security segregation and isolation. A suspicious program can be loaded into an isolated VM and executed, which is called sandboxing. If the program's malware, only the virtual machine will be impacted. These work great if you have forensic computers. It can be really good for that. Security concerns for virtual environments. Not all hypervisors have the necessary security controls to keep out attackers. Existing security tools were designed for single physical servers. VMs must be protected from both outside networks and other VMs on the same physical computer. VMs may be able to escape from the contained environment and directly interact with the host operating system. It's important to have virtual machine escape protection. So this whole thing basically means there's a lot of things that can go wrong if you do not configure your VMs correctly. Virtual machine sprawl is the widespread proliferation of VMs without proper oversight or management. And I've seen this happen. And when I actually took over the position that I had, I took over from someone who just didn't care and wanted to get out of Dodge. And I took over the web duties and all sorts of programming duties, but also came some server management functions with it, which were virtual machines. And there was no rhyme or reason whatsoever to the servers that were created. It was a mess. So this happens frequently, and it's very important to keep an eye on it, because it's tempting just to be like, oh, I'll just spin another one of these machines up and then go, what did they do that for? So keep an eye on it if you have this type of environment. Combating VM sprawl is called virtual machine sprawl avoidance. Installing a virtual machine manager can help. And that just gives you the ability to look at it and go, oh, okay, so this is what this is doing. So this is a virtual machine manager by SolarWinds, and it's just got your nice little desktop there that you can go through and click through and look at its memory utilization and everything and be like, okay, this one is obviously not doing well, or this one hasn't been used. It gives you all sorts of really cool information. Okay, knowledge check 2. What virtualization technology separates the control plane from the data plane on networking devices such as switches and routers? And don't be surprised. Oh, I'm just going to hit that one because it was one of those SDN, SDDV, so. I love how you keep bringing back that cope. So yeah, SDN, software defined network. Security network protocols. Common secure network protocols include SNMP, which is Simple Network Management Protocol, DNS, which you should have all heard, File Transfer Protocol, or FTP, Secure Email Protocols, Lightweight Directory Access Protocol, LDAP, and then there's IPv6 and IPv4. Well, I guess secure. IPv4 is not secure, so IPv6. SNMP is used to manage network equipment and is supported by most network equipment manufacturers. It allows administrators to remotely monitor, manage, and configure network devices. SNMP functions by exchanging management information between network devices. Each SNMP managed device has an agent or service, listens for and executes commands. Agents are password protected. Password is known as a community string. Security vulnerabilities were present in SNMP versions 1 and 2. Version 3 uses usernames and passwords along with encryption to address vulnerabilities. So that's your, make sure you know what your version you're using. DNS SEC. DNS is often the focus of attacks. So when we talked about DNS poisoning, ARP poisoning, DNS hijacking, all that, these attacks can be thwarted by using DNS sec. And that is additional resource records and message header information, which can be used to verify the requested data has not been altered in transmission. Using asymmetric cryptography, a private key that is specific to a zone is used in encrypting a hash of a set of resource records, which is then used to create the digital signature to be stored in the resource record. FTP, I'm sure pretty much everyone's heard of that. It's an unsecure, please remember that, unsecure protocol used to connect to an FTP server in order to transfer files. Methods for using FTP in a local host computer: use an FTP client, use a command prompt, and using a web browser. FTP vulnerabilities include, it does not use encryption. FTP using, file transfers using FTP are vulnerable to man-in-the-middle attacks, which is why if you see an FTP server running on your network, you really need to figure out what's going on. There are two options for secure transmissions over FTP, and you better hope you're using one of these. There's FTPS, which uses SSL or TLS to encrypt commands sent over the control port. Data port, or which is 21, and then data port 20 may not be encrypted, so make sure you're using the right port. Then there's SFTP, which uses only a single TCP port instead of 2 ports. All data and commands are encrypted. Secure email protocols. Well, because so many people use, especially third parties, I've run into this multiple times. They're like, oh, we just need you guys to open up so we can use FTP for blah, blah, blah. And if your network person is trying to be overly polite, sometimes they'll just open stuff up. And I have actually seen this happen, and like running through code going, wait a minute, you're using FTP back and forth on a daily basis, and this is not SFTP, it is not it is not any of the good things. You've got a big old hole that is just basically punched through all your security protocols. It's bad. So earlier email systems used 2 TCP/IP protocols to send and receive messages. So SMTP and POP. IMAP, those are the older ones. IMAP, or Internet Mail Access Protocol, is a more recent and advanced email system, like Google uses IMAP. As a means of security, a mail gateway monitors emails for unwanted content and prevents these messages from being delivered. A mail gateway can automatically and transparently encrypt outbound email messages. LDAP. A directory service is a database stored on the network that contains information about users and network services. The directory service also keeps track of all the resources on the network and a user's privileges to those resources and grants or denies access based on the directory service information. So your users access rights, file access rights, all the things. LDAP makes it possible for almost any application running on any computer platform to obtain directory information. A weakness of LDAP is that it can be subject to LDAP injection attacks. This may allow an attacker to construct LDAP statements based on user input statements. The defense against LDAP injection attacks is to examine all user input before processing it. IPv6 addresses weaknesses of IPv4 and also provides other significant improvements. It increases the number of available addresses significantly. It has enhanced security features. It can implement end-to-end encryption. This makes the man-in-the-middle attack significantly more difficult. It requires a lot more tools and know-how. It supports more secure name resolution. The secure neighborhood discovery SEND protocol can send cryptographic confirmation that an endpoint is who it claims to be, and this makes your ARP poisoning more difficult. Last, at least I'm hoping, last knowledge check. Which type of networking service is potentially susceptible to LDAP injection attacks? Directory service, domain name service, web service, mail service. Y'all still there? Oh, replies. Chirp. Just pick one. Yep. All right. Yay, that's the end of that one. All right, so that's it for our lecture tonight. Please get some work done on your Cengage as it allows you. If there are any problems, let me know. If other than the usual slow stuff, I will stop this recording here in just a second, get it uploaded, and then you guys should be good to go. I will see you for more lectures tomorrow. Have a good night.